Hello guys, in this video I'm gonna show you how to solve any electric circuit using the nodal analysis or nodal voltage method. Okay, so this method is basically based on the fundamentals that we learned so far, Ohm's law and Kirchhoff's law, but it makes the solution in a semi-automated way, you know, basically using this using this method we can like automate or make a computer program that can solve automatically circuits for us. That's the idea behind it. Okay, but it's basically ohms and Kirchhoff, nothing more. So as the name suggests, in this like method we search for the nodes. So the nodes will be our key like points or key starting points to solve the circuit. Basically, when I say node or point, basically I mean like the nodes that has or have like at least 3 branches out of it. Okay, so let's explain this method using like an example. So in the circuit in here, we have like a current source I naught, we have voltage source V naught, we have some resistances. Okay, and we need to know the current I flowing through the resistance R2. Okay, so here is the circuit. If you go down a little bit, here is a circuit with all the values in it. So R1 is 5 ohms, R2 10 ohms, R3 5 ohms, R4 2.5 ohms, I naught 0.8 amperes, P naught is 10 volt. Okay, so the first step in the node analysis is to search for the nodes. The nodes has at least 3 branches, and we have here 3. So I named them VA, VB, and VC. Okay, so that's the first step. Find the nodes that has at least 3 branches. Second step, pick any one of them, anyone, okay, and make it ground. Or you might say maybe in the real, like in the lab, for example, when I construct this circuit, it's not gonna be 0. This is just for the solution, At the end of the day, we need a voltage difference across the resistances. We don't care about like individual node voltages. Okay, so that's why we pick any one of them. We can pick VA and make it 0 ground. We can pick VB and make it ground. We can pick VC and make it ground. What I did here is basically picking VC and make it ground. But you can solve with VA or VB. That's fine. Okay, you're gonna exactly get the same, voltage drops across the resistances and the currents. This is what matters for us. The voltage across R1, across R2, across R3, across R4. The current that's flowing in R2 or the current flowing in R1, R3, R4, all these currents and voltage differences will be the same, whatever the ground nodes that you picked. Okay, so usually we choose the one that is usually at the bottom, because it's a ground. That's basically the reason behind it. Otherwise, you can pick anyone. That's why I picked VC. The third step is to go to the remaining nodes and apply Kirchhoff current law. That's why I said before, it's basically Kirchhoff and Ohm's law. Okay, so let's go to VA first. Okay, so let's remove these circles here. So VA, I'm gonna assume there are 3 currents because we have 3 branches here, R2 and R1 and R3 resistances branches. Okay, and I'm gonna assume 3 currents going out of VA. Okay, we learned before, guys, if you have a resistance like this called R, and there is a voltage here at this terminal called V1, there is another voltage here called V2. Okay, then the current, you can assume the current in any direction, whatever you like. So the current I here will be the node, the voltage of the node that the current is going from, which is V1, minus the current is the voltage of the node that is voltage is going to, which is V2, divided by the resistance. Okay, that's what I'm gonna do right now here. Okay, so let's check. Let's call, for example, this current here, I1, I2, I3. Okay, I1 is going from VA to this node here. We don't know this node yet. Okay, so let's bring it. So look, this is the terminal of VO, V node. V node has a voltage source here. The battery has like two terminals, the positive and the negative. So the negative terminal is connected to the ground. So this is zero. And we know also, if you have a battery like this, or like this, whatever you draw it, okay, this is the positive, this is the negative. If this is E, if this is V1, if this is V2, again V1, V2, E, whatever the symbol you choose. Basically, E is equal to the voltage of the positive terminal minus the voltage of the negative terminal. So the V naught here, in our case, equal to the voltage of the positive terminal, which we don't know, let's call it X, minus the voltage of the negative terminal, which is this one here, which is zero. Oh, so X is equal to V naught. Okay. Basically, what the battery do, it raises the voltage of its positive terminal in reference to its negative terminal by the amount of that battery voltage, which is E in this case, or V naught in this example. Okay, so X, let's remove X here and put V naught in green. Okay, so we know we can construct an equation for I1 now. So let's do that. Let's do that. So I1 equal to VA minus V naught, and V naught is known, it is 10 volt, and I naught is known as 0.8 amperes, divided by the resistance, which is R1. How about I2? I2 is the easiest. I2 is flowing from VA to the ground. VA is unknown. The ground is 0, which is VC, divided by the resistance, which is R3. How about I3? I3 is going from VA to VB and through the resistance R2. So VA minus VB divided by the resistance R2, which is, let's write it R2 as a symbol, then we substitute later. Okay, we know from Kirchhoff current law, the summation of the currents going into the node or out of the node, is equal to 0. Okay, so all of them is going out of the node. So the summation of all of them is 0. So I1 plus I2 plus I3 is equal to 0. So let's put the equations. That will lead to VA minus V naught over R1 plus VA. I2 is just VA minus 0, so it's VA over R3. Then I3 is VA minus VB over R2. This is equal to 0. Okay. Let's take VA as a common factor. So VA as a common factor here will be 1 over R1 plus 1 over R3 plus 1 over R2 minus VB over R2 minus V naught over R1. This is equal to 0. Okay? This is equal to 0. Why I wrote it in this like shape? Because whenever you solve with the nodal voltage analysis or method, you're gonna get something like that. The voltage of the node that we solve at it right now, which is V1 and VA in this case, multiplied by the reciprocal of all the resistances connected to it, and V1, VA, I'm sorry, is connected to R1, connected to R2, connected to R3. Always minus, as long as you assume the current like that. You have to assume the current going out. You can assume the current going in too, but all the signs will be, flipped from negative to positive or positive to negative. So, but usually we assume the current going out, but you can solve assuming the current is going in. Minus the connected node, which is VB in this case, okay, the other node, divided by, again, the resistance between the two nodes. Okay, then the current sources or the voltage sources. So we have the voltage source here, V naught, so V naught divided by R1. The only term that is positive is VA. Okay, so let's now substitute and write this in a cleaner way, we can say. So VA unknown, R1, how about R1 is 5, so 1 over 5, R3, 5 again, R2, I believe 10, VB is unknown, R2 is 10, V node is 10 volt, and R1 is 5, equal to 0. So so 1 over 5 plus 1 over 5 is 2 over 5. You can multiply the numerator and denominator by 2. It's going to be 4 over 10. So 4 over 10 plus 1 over 10 is 5 over 10, which is half. So that would be reduced to half. So VA half minus VB 1 over 10, right? Equal to 10 over 5, which is 2, with minus going to the next side will be 2. So that's the first equation. Remember, we have two unknowns here. We have VA is unknown and VB is unknown. Okay? So once you, so we need at least two equations to be able to solve, this system, to get VA and VB. So we get one now. So we need another one. So the other one will come from solving Kirchhoff current law at the next node, which is VB. So what we did with VA, we're gonna do with VB. So again, we're gonna assume three currents going, all of them is going out as usual, and let's call them, I, 4, 5, 6. Okay, because we already used I1, 2, 3. So I4, I5, I6. Okay, well, let's solve with another color. So I4 equal to I4 is flowing from VB to VA. So it's equal to VB minus VA over R2. VB minus VA over R2. Then I6 or I5, let's start by I5. Oh, I5 is good. That's very good, like, good to know. So I5 is flowing in the branch of the current source. There is a current source here that provide the current, constant current, equal to 0.8 amps. Okay, 0.8 amperes. But it's flowing in that direction. So this is I node. It's opposite to I5, but it's the same branch. So it's same charges, same electrons. Okay, same rate of electrons. So I5 will be minus I node. Okay, that's easy, very easy. So I5 will be minus I naught, which is minus 0.8. Then final I6 is flowing from VB to VC, which is a ground, and it's gonna be through R4. So I6 is equal to VB minus 0 over R4. Yes, R4. Okay, and the summation of all this current, because all of them is going into or going out of VB, is equal to 0. So VB minus VA over R2 minus I naught plus VB divided by R4 equal to 0. In the first equation, I started by VA, so I'm gonna start also with VA. So I'm gonna take VA on the side here as a first term, so minus or VA multiplied by minus 1 over R2 plus. I'm gonna take VB as a common factor because it's in here and here. So VB divided by multiplied by 1 over R2 plus 1 over R4. And I'm gonna bring this guy to the other side, the right hand side with positive sign. So plus I naught. Again, I insisted to make it in that symbolic form to show you that usually you're gonna end up with, or always you're gonna end up with, a positive term, which is the term that you solve at, the node that you solve at, which is VB in this case, multiplied by all the summation of the reciprocals of all the resistance connected to it. So VB is connected to R2 and R4. Okay. You're gonna have another term or terms, if you have multiple nodes, with the other node connected that VB is connected to, which is VA, divided multiplied by minus of the reciprocal of the resistance between them. And on the other side is current source or voltage source, whatever. Okay. If it's a voltage source, it's gonna be divided by the resistance, like in that case here. In the first case, where it is V, yeah. And if it's a current source, it's gonna be the current with no division. Okay. So let's now substitute to make it simpler. So R2 is it's 10. So VA multiplied by minus 1 over 10 plus VB. R2 is 10 again. And R4 is 2.5 ohms. 1 over 2.5 equal to, and I naught is 0.8 amperes. Okay, that's good. Let's simplify further. So VA minus 1 over 10 plus 1 over 2.5 can be, if we multiply 4, numerator and denominator, so 4 divided by 10. 4 multiplied by 2.5 is 10. So it's going to be 1/10 plus 4/10. It's 5/10. 5/10, 5 over 10 is half. So I forgot VB here. Equal to 0.8. And we put this in a rectangle like that. And this is the second equation in our two unknowns, VA and VB. Okay? So what I'm advise you to do right now is to go to ChatGPT, and the ChatGPT can solve these two equations for you. Or if you have a calculator, you can use your calculator. So in the ChatGPT, what I wrote is exactly like this. Let me share my screen here to show you what I wrote exactly in a ChatGPT to solve these two equations. So this is what I wrote here. Hey, Mr. ChatGPT, solve the following two equations in two unknowns. And I wrote them. And I just replaced the VA and VB with X and Y. This is much better, because VA is two letters, so it might confuse the ChatGPT. So I make it X and Y. X is VA, Y is VB. It gave me the solution is a very, X is 4.5, Y is 2.5. I didn't know what is this, so I have some doubt. So I just asked him again, what is X and Y exactly? And he gave me the final solution, 4.5 and 2.5. And that's actually the correct solution. So let's go back. So here, VA, by the way, we didn't finish. So VA equal to 4.5 volt, and VB is equal to 2.5 volt. Okay? Now, Why we didn't finish? Because the actual question was find the current I. This one, the current that flows from VB to VA. Okay, so that's very basic, you know. So the current I is equal to VB minus VA over the resistance, which is R2, I believe. Let's check. R2, which is 10. Yeah. So VB is 4.5. I'm sorry. VB is 2.5, not 4.5. VA is 4.5 and R2 is 10. So it is 2 divided by 10, which is zero point 0.2 amps. Okay, zero point 0.2 what? 0.2 amps. And you can continue, you know, and find all the currents and all the voltages, you know, in basically in this circuit. Okay. So for example, if you wanna find the current flowing in R4 like that, so it's VB minus 0 over R4, and so on for the other. Okay. That's basically it, you know. So the question now, can we solve this same circuit using what we learn in Kirchhoff and Ohm's fundamentals? Of course, yes. And of course, you have to have the same solution. Otherwise, you have something wrong. Either the first one is wrong, or the second one is wrong, or both are wrong. You know, they have to be matched. You have to get the same answer again. So that's what I'm gonna do. So in the next video, I'm gonna solve the same circuit, same exact circuit, okay, but using the fundamentals, Ohm's law and Kirchhoff law. So see you. Bye bye.